So we've talked about taking a derivative. In this case, if we have f of x and we take the derivative, we would call it f prime of x. And it would give us, what, 6x plus 2. That would be the derivative. This tells us the gradient, or the slope, at any point of the curve for the same x value. Well, what if instead of f of x, we have y? Well, do we write y prime? You actually can. You can write y prime over here equals 3x squared plus, well, sorry, not 3x squared. It'd be 6x. 6x plus 2. You get the same exact thing. Wow! Sometimes they also call it, if you take it again, it would be y double prime. That's another way to write it. Another way you might see this would be dy. You've taken the derivative in respect to y, which now gives you dy. And over here you would get 6x plus 2 dx. Ooh, okay. The dx means you've taken the derivative in respect to x. Dy means you've taken the derivative in respect to y. All right, let's try these through real quick. If we take the derivative, that gives me 12x squared plus 3. All right. Over here, y goes to y prime, gives me 12x squared plus 3. All right. Over here, gives me 12x squared plus 3. If you think you end there, you get it wrong. No! Now this is all about notation, using the proper notation. How do I properly finish writing this? If I've taken the derivative of y, I'll also have to take the derivative of x. What's the notation to say that we've taken the derivative of x? You have to write dx. All right, here's a little bit more of an intense version. If we're taking the derivative, hold on, we've got the derivative of y and we've got the derivative of x. Ah! Well, you just do it the same way we've been doing it. So we've got y. How do you take the derivative of y squared? Well, you bring the 2 down. That gives me 2y plus 3 dy, because we just took the derivative of y. But then over here, well, bring the 4 down. 4 times 4 is 16x cubed minus 3 dx. See, that's why it's important to use the dy and dx to show that this entire equation is in fact a derivative. Okay, we don't use y prime in this case. You would use dy and dx. Let me do another problem. All right, I want to take the derivative here, so I'm going to start off with my y's and just move left to right, because that's how I read, and I just go left to right. Here we go. So this gives me 25y to the 4th minus 6y. I don't have to do anything because the 2 minus 1 is just 1, which is y. Okay. Don't forget the dy equals 24x cubed minus 3 times 3 is 9x squared plus 2. What's the last piece? dx. I've taken the derivative in respect to y and the derivative in respect to x. Okay? We can't forget the dy's and the dx's. It's notation. That's all it is. It's just notation. It's another way to write it.